Hello, my name is Angelo Bravo, and today I'll be presenting a case study on beers, specifically the ABV, the alcoholic percentage of a beer, and the IBU, International Bitterness Unit of beers. And IBU tells us how bitter a beer is. So in this case study, I will go over the missing data in our beers data set and how we filled in that data to further our analysis. And we will also analyze ABV and IBU by state. We will summarize ABV by showing the distribution of ABV by different beer categories. And we will also demonstrate a correlation between IBU and ABV. We will also demonstrate that IPAs and ales differ in ABV and IBU using a KNN, K-nearest neighbors classification method. We will also recommend to you what ABV your IPAs and ales should contain. So here we have a histogram of missing data on the left, and the red represents the missing data. As you can see, only IBU and ABV in our whole data set are missing data points. The rest of our factors are not missing data points. And 39% of our observations in our whole data set are missing IBU ratings, and 2.6% are missing ABV percentages. So, in order to fill in this data, we use the mice package in R, and we use the method in the mice package called predictive mean matching to fill in the data. So we generated 5 models using predictive means matching, and those are in red, and our original density plot of ABV is in blue. So we wanted to find the model for that most closely resembled the original ABV density of our data. So we went with model number 4, which most closely resembles the original data. So here we have a median IBU by state, and so we can see here that West Virginia's beers have a median bitterness, have the highest median bitterness out of all the states, and New Hampshire's beers have the lowest median bitterness out of all the states. Here we have a bar chart of ABV percentage by state, and we can see that Kentucky's beers have the highest median alcoholic percentage, and Utah's beers have the lowest median alcoholic percentage out of all the states. So here we have 4 box plots, one for ales, IPAs, lagers, and others. And we can see here that the median ABV for IPAs is the highest out of all the groups. And we can also see that IPAs and lagers have fairly normally distributed ABVs, while ales and others have more right-skewed ABV distributions. So here we decided to make a scatter plot of IBU and ABVs to see if there was a correlation between them. And we can see here, after fitting a regression line, that there appears to be a positive slope in our regression line, indicating that there may be a correlation between IBU and ABV. So here we can see that as IBU increases, our ABV tends to increase, and which makes sense because as your drink becomes more bitter, it tends to have more alcohol in it. So is ABV and IBU different between IPAs and ales? We wanted to test this using a K-nearest neighbors classification method. In order to do this, we created a training set of 50% IPAs and 50% ales, and we wanted to test IPAs and ales against this training set of evenly distributed 50-50 IPAs and ales to see if we can get a predictive accuracy greater than 50%, or a coin toss, or a random guess. And we actually did get a much higher accuracy than 50% in all of our 10,000 iterations or model fittings of KNN. So our lowest predictive accuracy was 74%, and our highest was 93%. And so that range is much higher than 50%, showing that we can accurately cluster IPAs and ales with IBV and ABU, showing that they are indeed different for IPAs and ales. And here we have a mean accuracy for 100 iterations for each K. And you can see how it kind of keeps on increasing until about 60 Ks, and then from there begins to decline slightly. So, what ABV should your ales and IPAs contain? Here in the red we have IPAs, in the light purple we have ales, and in the dark purple we have both combined where they overlap. And as we can see here, the IPAs appear to have a higher center of ABV than the ales. And we wanted to test this using a two sample t test, and they did indeed have significantly different means of ABV. So, what ABV should they contain? We decided to create a 95% confidence interval from our data for ales and IPAs, and we recommend that your ABV for ales lie within 5.59% and 5.73%, and the ABV for your IPAs be between 6.79% and 7.01%. And when you make them these ABVs, the IBUs they should be the bitterness of beers of these in within these intervals should be ones that your consumers are comfortable with, because as we saw earlier, there seems to be a correlation between ABV and IBU. So you can guarantee a satisfied customer with these ranges of ABVs for IPAs and ales. I hope you gained some deep insight on the ABV and IBU of your beers, and hopefully you can use this information in the production of new beers that you wish to put out on the market. And thank you for listening to this presentation, and have a good day.